Some scientists are working around the clock to get a thorough understanding of the planet Earth, and their efforts are beginning to bear fruit in the shape of various findings that they have recently shared with the rest of us. Recent Icelandic finds have baffled scientists. Recent discoveries from the Fagradalsfjall eruptions in Iceland have altered our understandings of how volcanoes function. Earth scientist Matthew Jackson of the University of California, Santa Barbara, and his team discovered a process that is far more dynamic than anybody had anticipated in the 2 centuries that scientists have been researching volcanoes when sampling magma from Fagradalsfjall volcano in Iceland. Let's study a bit about Iceland first, then move on to the findings. Where is Iceland? Iceland is situated between the North Atlantic Ocean and the Greenland Sea. It's somewhat smaller than the state of Kentucky and is located northwest of the United Kingdom. The capital of Iceland, Reykjavik, is located in the northernmost part of the Earth and is the westernmost country in Europe. A glacial ice cap covers 11% of the nation, which is encircled by sea. Rising sea levels and glacier melting might have disastrous effects on Iceland if global warming continues. Iceland is a volcanic island that frequently erupts. An eruption of the Eyjafjallajökull volcano in 2010 at the height of 5,466 feet, 1,666 meters, caused weeks of disruption in European air travel. The area is a plateau with ice fields, mountain peaks, and fjords, which are large inlets that glaciers have sculpted out of the landscape. Iceland's Fagradalsfjall eruptions change what we know about how volcanoes work. Earth scientist Matthew Jackson of the University of California, Santa Barbara, and his team discovered a mechanism that is far more dynamic than anybody had anticipated in the 2 centuries that scientists have been researching volcanoes when sampling magma from the Fagradalsfjall volcano in Iceland. The journal Nature has published the geologist's results. Jackson was in the right place at the right time to witness the formation of Fagradalsfjall, a fissure in the lowlands of southwest Iceland that split and erupted with magma in March 2021. It took a break, a pandemic, and 780 years of subterranean rock melting to put Jackson in the right place at the right time. He claims that at that point, everyone in the Reykjanes Peninsula was prepared for an eruption of some type. He describes the 50,000 or so earthquakes, some of magnitude 4 and higher, that rattled the ground for weeks and had the majority of Iceland's people on edge as the earthquake swarm was tremendous. Nevertheless, the lack of sleep was worthwhile, since seeing the lava bubble up and spew out of the relatively empty Geldingadalur region's hole in the earth fascinated them. Both tourists and scientists descended to the region to witness the formation of the newest portion of the Earth's crust. Due to the sluggish flow of the lava and the winds that carried the toxic fumes away, they were able to approach near enough to continually sample the lava from the outset. The geologists at the University of Iceland, under the director of Sæmundur Halldórsson, were attempting to determine the origin of the magma's depth in the mantle, the depth at which it was held before the eruption, and the conditions of the reservoir, both before and after the eruption. Due to the unpredictable nature of the eruptions, the risk and harsh circumstances, as well as the isolation and inaccessibility of many active sites, questions like these, although essential, are some of the largest obstacles for those who research volcanoes. According to Jackson, the underlying theory was that a magma chamber gradually fills up over time. The magma becomes well mixed and then drains throughout the eruption. He continued to say that those investigating volcanic eruptions do not anticipate detecting major changes in the chemical composition of the magma as it flows out of the ground because of this well-defined 2-step process. Long-lasting eruptions of Hawaii's Mount Kilauea cause very minimal changes over time. However, the rate of change for important chemical markers were more than a factor of 1,000 greater in Iceland. Jackson went on to note that the Fagradalsfjall eruption had greater compositional variety in a month than the Kilauea eruptions had over decades. The full spectrum of chemical compositions that had ever erupted in southwest Iceland in the previous 10,000 years was sampled at this eruption throughout the first month. This, unpredictably to experts, results from successive batches of magma moving into the chamber from deeper in the mantle. Jackson used an illustration to describe the phenomena. He instructed you to visualize a lava lamp in which a hot light bulb at the bottom warms a blob, which rises, cools, and finally sinks. The Earth's mantle, which extends from the top of the core down underneath the tectonic plates, functions somewhat like a lava lamp. He says that when the mantle rises due to the heat and plumes develop and rise buoyantly toward the surface, molten rocks from these plumes gather in chambers and crystallizes, gases escape through the crust, and pressure increases until the magma finds a means to escape. According to the article, for the first few weeks, the reservoir, which is located approximately 10 miles, 16 kilometers below the surface, had been collecting the predicted depleted magma type. However, by April, it had become clear from the available data that the chamber was being refilled with deeper, richer melts of a different composition that came from a different part of the Icelandic upwelling mantle plume, with a higher magnesium concentration and a larger amount of carbon dioxide gas. This new magma had a less altered chemical makeup, suggesting that fewer gases from this deeper magma had escaped. The deeper, richer form of magma dominated the flow by May. In a plume-fed hotspot, these sudden dramatic changes in magma composition have never been seen in close to real time previously. According to Jackson, these compositional changes might not be all that uncommon. The opportunity to sample eruptions of this early stage is uncommon. For instance, the most recent eruptions in Iceland's Reykjanes Peninsula happened 8 millennia before the 2021 Fagradalsfjall eruption. He believes that this recent activity in southwest Iceland heralds the beginning of a fresh volcanic cycle that might last for centuries. Since lava flows from the latter stages bury the earlier stages of most eruptions, they frequently don't have a trace of them. The researchers claim that this effort allowed them to observe phenomena that weren't supposed to be feasible, but had never been seen in person. Although it is not yet apparent how typical this occurrence is of other volcanoes, or what role it plays in causing an eruption, this discovery poses a significant limitation for scientists in how models of volcanoes throughout the world will be created. It serves as a reminder to Jackson that the Earth still has mysteries to reveal. Is there a hidden continent under Iceland? The whole continent of Icelandia, which is primarily buried beneath the Atlantic Ocean, may only have Iceland as its exposed portion. This concept was written about in the book In the Footsteps of Warren B. Hamilton, New Ideas in Earth Science by Gillian Folger and her Durham University colleagues. On the mid-Atlantic ridge, where two tectonic plates are gradually drifting apart, is Iceland. Along the ridge, magma wells up before cooling and hardening into rock, adding to the seafloor. However, Folger and her group offer a different theory. Instead, they contend that Iceland and a sizable portion of the nearby seafloor are composed of continental crust. This undiscovered continent of Icelandia, if it indeed exists, has a surface size of 600,000 square kilometers. Icelandia would be a remnant of Pangaea, a supercontinent that formerly connected the continents that are today on either side of the Atlantic Ocean. Pangaea existed millions of years ago. Since then, the movement of the plates has caused the continents to separate. Folger believes that Icelandia is a piece of Pangaean continental crust that has survived and is currently under Iceland. Funding is available for Folger's team to bring back zircons from Iceland. The zircons should provide weight to the theory that the deeper strata constitute the Pangaean continental crust. The oceanic crust, which is continually being generated and destroyed, is normally just a few 100 million years old, but the continental crust is frequently billions of years old. If the zircons underneath Iceland are older than this, the team's hypothesis would be supported. Does Iceland have Vikings? Some of Iceland's most breathtaking landscapes, including magnificent waterfalls, enormous glaciers, and expansive black sand beaches, can be found in the south of the island. But the area is also rich in Viking heritage, including newly unearthed 10th century remains. In the 9th century, Vikings from Scandinavia and the British Isles arrived in Iceland and struggled through starvation, severe winters, and volcanic eruptions. To survive, Iceland's early inhabitants constructed huge cave networks, some of which are just now emerging from millennia of underground burial. In the country's south, excavations of man-made Viking-era caverns at Oddi have uncovered a vast network of connected structures that are older and larger than first believed. The excavations, according to archaeologists, demonstrate that Oddi caverns were first explored in the middle of the 10th century. Oddi was not just the center of Viking power and influence, but it was also a hub for study and culture. John Lofsson, Smunder's grandson, nurtured the author Snorri Sturluson as a result. One of Iceland's most prominent historical personalities, Sturluson 1179 to 1241 was a chieftain, storyteller, politician, and author. He was credited with several of Iceland's most notable Middle Ages literary masterpieces, notably Egil's Saga. The earliest dated example of a man-made cave in Iceland, according to Ms. Orsdottir, was discovered during the excavations at Oddi. By lining up the layers of volcanic ash and other debris with the dates of known eruptions, they have been given a date. The cave at Adi is a Viking period structure, contributing to our prior understanding of the construction methods used by the early immigrants in Iceland and the inhabitants of North Atlantic. It appears to have been dug out in the 10th century. Their findings indicate that man-made cave construction and usage in Iceland were widespread and began far earlier than previously thought. They assume that many constructions of this kind have been abandoned and walled up due to their experience in Adi. They expect to be able to continue the excavation to learn more about how long these caverns were inhabited, how that usage evolved through time, and whether any cave system features to show signs of human habitation. One of the finds is a cave that may have been used as a cow and horse shelter. These structures, called Nautahelurs, are mentioned in Bishop Orlocker's Legend of Saints from the 13th century, which includes a description of a cave collapse. Archaeologists are also susceptible to collapses. Sandstone, which absorbs water and is prone to crumble, is used to carve out the caverns, but it's anticipated that the discovery would attract many tourists.